Hi there, Dominic. Welcome. I think we're still waiting for Dominic to come up on stage. And once he does that, we can get started.
Hey.
Hi, Dominic. How are you?
I'm good, thanks. Can you hear me?
Yes, sir. Loud and clear.
Fantastic.
Dominic, welcome. Whale Coin Talk community, welcome. We have ICP in the house today. Dominic, before we get started, do you want to give us a quick background into your origin story, your career trajectory, and how you ultimately made that leap into Web3 and started ICP?
Sure, I'll try and condense it. I've been around for a long time. So I've been, coding for more than 40 years. God help me. And, over the years, I've created all kinds of different system. I suppose you'd have to call me a geek of some kind. I'm pretty into particularly distributed computing. I started messing around with cryptography back in 1999. I was creating a distributed system called smart drives. And that involved obviously encrypted links, and also I was creating my own certificate authority, which involved certificates that were ASCII text, so you could copy and paste them into emails and things. And back then I was using a library called Crypto++. I was a C++ programmer, and I was using a library called Crypto++, created by a guy called Wei Dai. And on his website, I believe it's even still there was this thing, a sort of, I won't call it a paper because it was all just text, but kind of a white paper for this thing called B-Money. And honestly, I read it and I couldn't make head or tail of it, but I saw there was something very interesting there. I just didn't have time to delve deeper. Scroll forward, another 10 years or so, and I'd created a massively multiplayer online game called Fight My Monster that actually grew to 3 million users in the end. So it was a sort of success. And this thing didn't involve cryptography, but it was, I built a lot of these kind of distributed systems that supported it and a very high level of interactivity. So any user can interact with any other user. And it uses a decentral. We were the first sort of service to use a thing called Cassandra, which is kind of it's a database with a decentralized architecture, and that had helped me scale out because whenever I needed more capacity, I could just join a new node to this cluster, and the sort of capacity of the network to store data and process computations increased. So anyways, I was looking for something else. And in 2013, sort of April, Bitcoin went through one of its crazy pumps and caught my eye. And I started trading Bitcoin and obviously read the white paper and was enthralled. And so I'd sort of been kind of conditioned previously to find this very, very interesting. And I did. And by the end of 2013, I wanted to create this thing called Gamecoin because, I was still working in the, games field. And my idea was, I was going to have a cryptocurrency that people could use to buy and sell virtual goods and, move value between games. And I realized that, proof of work wouldn't work in this setting because I needed a cryptocurrency that would process very large numbers of transactions a second, inexpensively, because this is virtual goods, not Bitcoin. So I started sort of looking at some of the early work people were doing with sort of proof of stake cryptocurrencies, looked into some of their workings and decided that they weren't really fit for purpose, and began researching how to build cryptocurrencies that might scale, so they could process, I was targeting hundreds of thousands of transactions a second, and created this project called Pebble. And I pretty much spent 2014 almost full time just working on crypto research. I think I was the first person in the space really to try and repurpose what's known as Byzantine fault-tolerant computing techniques from the sort of distributed computing branch of computer science, and try and repurpose those techniques and that math for the decentralized blockchain setting. I think I was probably the first person to mess around with different sharding architectures. And so came to kind of October 2014. I never published the paper. I distributed it to a bunch of early insiders, like Vitalik had it, Nick Szabo had it, and so on. But I didn't really push ahead with Pebble. I'd sort of paused. And part of the reason was I was involved with the early Ethereum scene. And I realized that, blockchain was going to be about much more than just tokens. It was going to be about computation. And then I heard this phrase, world computer. And as soon as I heard the phrase world computer, it's like a light went on. And that was, my focus from then on. But my interpretation of that phrase was very different to everybody else. So within the Ethereum community, I think world computer just meant a blockchain where you have smart contracts that can do a handful of transactions a second and so on. When I heard that phrase, I immediately imagined a kind of blockchain singularity because, my experience with, cryptography generally and distributed computing made me believe that inevitably we'd be able to create a blockchain that could really play the role of a true world computer, and we'd see this blockchain singularity where every system and every service on Earth, or at least the vast majority of them, would run on blockchain. And I believe that for some simple reasons, essentially related to the properties that smart contracts have. So, smart contracts are just software, right? But it's a new kind of software. And smart contracts are tamper-proof. So they're guaranteed to run, when you invoke a smart contract, you're guaranteed to run exactly the code you expect against the data you expect. I mean, if your code's wrong, obviously things they can malfunction, but you're always going to run the code you want to run and against the data it should run against on the chain. And that's immensely powerful. It's, you don't need a firewall to protect Bitcoin. You don't need a firewall to protect, basic DeFi smart contracts on Ethereum. And of course, when you build, a mass market service, say, on the internet computer, you don't need a firewall to protect that either. And eventually, enterprises are going to flock to World Computer and build their systems there because they don't want to get ransomware and hacked anymore. So that was the first thing, and I saw that smart contracts are unstoppable. That's another great characteristic. Smart contracts can run autonomously. That means you can create code that either can't be modified and it just exists as some kind of like business rails that parties can use without fear that it will change underneath them. Can be used it's fantastic for things like international finance. But autonomous code can also be something very complicated, like a social network that runs under the control of a DAO, a decentralized autonomous organization. And I believe that in the future, the vast majority of not only services but also systems will run under the control of DAOs. Services, will run under the control of DAOs because in the future, our internet services will be kind of like communities, right? They'll run under the control of a community rather than a company and a board of directors and a CEO and all that kind of stuff. And I think enterprises will use DAOs to control their critical infrastructure because it's more secure. So I'm looking at this, and of course there's tokenization and identity and all that kind of stuff. So I'm looking at this and I'm thinking, right, all things being equal, if you can build a world computer, it's got this great advantage, first of all, because it's a public network and nobody wants to be a captive customer of big tech, and whether that's Amazon Web Services or Google Cloud. It's a public network. So this is like the internet versus AOL. Everyone's going to prefer the internet. Everyone's going to prefer a world computer. And when people build on this public network, they're going to get these amazing benefits. Tamper-proof code, unstoppable code, autonomy, tokenization, all of that. All that's necessary is to build a world computer that can run with efficiency in the same ballpark as traditional tech, and is solves problems like web serving, because unless you have a blockchain where the smart contracts can serve web, well, you're always going to be reliant on building stuff on big tech's cloud and things like that. So I set myself to that, and really the name Dfinity came about in 2015. It's just a shortening of decentralized infinity, and originally it was meant to be Ethereum 2.0. That was the initial plan. If you go back to sort of 2015 or look on YouTube, DevCon 1, Dominic or something like that, you'll see that I used to give a lot of talks, things like San Francisco Bitcoin Devs, early Ethereum conferences. But if you look at like Ethereum 2 now, there's enormous similarities in its architecture to the kind of architecture that I was proposing, in early 2015. But I sort of realized at some point, like, this isn't going to work. These guys want to move ahead quickly and all the rest of it. Whereas what I want to do is going to involve years and years of R&D. So Dfinity became its own separate project, and we sort of did a public ICO. The Single String Lab started funding the project in 2016. The foundation credited the ICP ledger and did a public ICO in February 2017. At which point one ICP cost you 3 cents. And we set about building an organization that would be capable of developing and realizing this vision, which would necessarily involve, a lot of novel cryptography, novel work with, emerging virtual machines like WebAssembly, completely new kind of execution environment for smart contracts. So smart contracts on the internet computer are asynchronous, which means they can run in parallel. New ways of thinking about sharding, because to me, if you have a sharded network, it's sometimes hard to call it, one blockchain. In some ways, it's really lots of blockchains, and we wanted to create, one blockchain really that would just, scale out without bound. And of course, there's usability issues, like, on the internet computer, you've got something called reverse gas. Smart contracts pay for their own computation, and that means that smart contracts can create a web user experience, and the user can interact with them without having to hold tokens. We worked away for a long time, and finally the internet computer launched May 2021. We had no idea, we were really an R&D organization. We walked into a number of traps, some very mysterious price manipulation went on with FTX and things like that, and we just, there's too much to tell you. It was kind of hell on earth. But despite everything, despite the crypto press, which really kind of represents vested interests, not reporting on us even though we have the biggest R&D operation in blockchain by far, we actually have the biggest team of sort of noteworthy cryptographers in the world, far bigger than Google, say, and probably bigger than the NSA. So, but we were sort of blocked out. Everyone was very worried about this internet computer thing. But nonetheless, the internet computer has been running for almost 2 years now. It's had no downtime. The community has been growing, and they've been building things that you just cannot build anywhere else. Like, you've got like, SocialFi, like a chat service that just fully decentralized with a DAO running end to end on the internet computer. which are really, I believe, going to change the face of the internet. And it's a much more profound kind of Web3. We've also got DeFi that is unlike any DeFi seen anywhere else. You've got order book exchanges, and that's going to, so where you've got an exchange that looks like Poloniex or FTX, except it's running 100% of the blockchain. Even the user experience is coming from the blockchain, and this is going to dovetail very nicely with this certain new technologies. It's related to a thing called chain key cryptography that powers the internet computer. But smart contracts on the internet computer can actually create transactions on other blockchains, which is a huge, mind-bending feature that I think people are just beginning to get to grips with. So things have gone well. Adoptions, the thing's been running. Dfinity is contributing to the internet computer space just as aggressively as it was before. With constantly releasing technological improvements, which are proposed to the network and adopted, and the community's building out. And I think as people find out about the internet computer, sentiment around it's constantly getting better too.
Yeah, I would agree. And I don't want to tarp too much or talk too much about all the FUD of 2021. I am aware of the price manipulations that happened by FTX and Alameda. And I think a lot of people, including myself at the time, would hear whispers of FUD about ICP and didn't give it a time of our day. Didn't give it time of day. And so I'm approaching this as a layman, and I think that a lot of people in the audience are also approaching this as a someone that hasn't heard too much about ICP, but is approaching it with an open mind. And so if you could kind of explain how ICP is different than the internet that we understand today, and you kind of elaborated on how it's different from other blockchains, and give us a 40,000 foot overview in simple terms and explain to someone who's non-tech savvy, like how people are going to be interfacing with this. What's the end game versus kind of the web 2.0 that we interface with today, where a lot of data and a lot of the content and a lot of everything is controlled by a few big tech players.
Okay, so the internet computer is obviously, it is crypto. It's a crypto project, but the aims are pretty broad, and so you have to understand it in a broader context. So if you rewind to the sort of 1990s, I think I was first messing around with Mosaic in like 92 or something. There was this big debate, believe it or not, about whether everybody should be connecting up with a sort of private or consortium networks like AOL, CompuServe. Microsoft proposed this information superhighway thing, and the proponents of these kind of private networks were saying things like, well, look, the internet's going to be unsafe, it's unregulated, but we're going to create this walled garden, and we're going to curate all the content, and users are going to much prefer that. And we know how that went, right? In the end, everybody wanted the free and open, permissionless internet, and it provided this free market that spurred enormous innovation as well as social and political freedoms. Simply put, imagine that Bob wants to create some website that does something, and Alice wants to create a competitive website, right? So if Bob sort of launched that website within CompuServe or something, well, sooner or later, Alice might come along to the owners of CompuServe and say, hey, look, if you slow down Bob's website, I'll give you some stock in my company, right? It wouldn't be a level playing field. Or maybe, CompuServe would just say, sorry, Bob, we've decided to work with Alice. You can't run your website anymore. On the internet, meanwhile, is open and permissionless. So, Bob has his website and Alice can create her website, but it's not possible for them to interfere with each other. Everybody can access the internet and everybody can serve content over it. And that really, informs a lot of the purpose of Dfinity and its work with the internet computer. We see the internet computer as an extension of the internet. The internet is a network that connects everybody and everything. And by the way, back in the 90s, that was still a difficult thing to explain. Like for years and years, people found it hard to get their head around the internet. But now we treat it like an essential public utility, like water. You just expect the internet to work. Of course, I'm here in Zurich and someone's in America and we're chatting on Zoom and it just all works, right? Of course it does. But 15 years ago, people were still like scratching their heads. Sorry, not 15 years ago, 24 years ago or something, right? 24, 23 years ago. Okay, so the one thing though, the internet connects everybody and everything. The one thing it didn't do is provide a platform for creating things that had similar properties. It just did connectivity. And the consequence was that eventually, as so many things in tech do, we saw this consolidation of power and data and created by network effects. So, now, the vast majority of systems are running on the corporate cloud. So they're not running on the internet. They're running essentially on these computers in these giant mega data centers owned by people like Amazon Web Services, paying, money to Amazon and, to run on this proprietary infrastructure. So they've made their foundations, they've let somebody else provide the foundations, which is a very dangerous thing to do in the first place. And then in addition to that, we saw, organizations like Facebook, in a way, and Google capture all the user data and then gate it. And initially the web was more open and these big players provided APIs and there's this notion of the programmable web. Of course, over time, that sort of fell away and we're left with a kind of much more monopolistic ecosystem that we have today. And there are lots of problems with it. It's anti-competitive. The power of these monopolies is just overwhelming. That means the innovation is stifled. Users don't get as rich an ecosystem as they might otherwise have. And there are inequities, right? Because users are contributing the data, but they're not getting anything back. And of course, there are political dangers as well. I mean, big data and it's also a platform for big government and surveillance. And, it's a bit like the banking system, you're a bad guy because you're into crypto, we're going to debank you, right? Imagine being, de-interneted, right? It wouldn't be good. And, we're seeing some signs of that. I mean, people are trying to hold back because they, don't want to everyone understands the dangers, but, I think it was 2021, Parler was kind of, in inverted commas, de-interneted, deplatformed by Amazon Web Services. They, Jeff is a Democrat, doesn't like Trump, and you've got all these kind of Trumpies, on this thing, Parler, and so they just sort of switch it off. And, irrespective of your politics, I think it's fairly plain to see that's a bad idea and a very slippery slope. So, people like me believe in a different kind of internet. What we want to do is kind of extend the internet so that you can actually build on it, right? And, it's not enough just to have, a political belief. Yeah, of course, everyone prefers the internet to AOL, CompuServe, and Microsoft's Internet Information Superhighway, or whatever it was. And of course, that's better. And we can see all the benefits that have accrued to our global society as a result of the internet. And so, prima facie, if you look at it, yeah, sure, like, the internet computer, everyone building on a world computer is going to provide enormous advantages over everybody building on Amazon Web Services and so on. But the devil's in the detail, like, how's that going to be done, right? And how is this internet computer going to provide transformative, game-changing properties that will eventually ensure its success, that people will choose to build on the internet rather than on Amazon, say. And why will entrepreneurs choose to build with new models, like new Web3 models, where instead of their company being in charge, they and their company being in charge of the services they're building, that the community is in charge instead. Like why are people going to do that? And so you have to think the whole thing through from end to end. And when you do that, you realize that this is a technically challenging project, and that's why it's taken Dfinity years and years and years to really get the internet computer to where it is today. And although we keep on rolling out new advancements, and developing them, proposing them to the internet computer's governance system, and oftentimes they get adopted. It still takes a long time. So, but we're in it for the long term, and I think we've reached a point where there's some really crazy big things happening now on the internet computer already. So, for example, here in Switzerland, we got, for example, a big bank building on the internet computer, and we're happy for this to go slowly. And I think once that project, once the bank releases details of the project, people will realize that it's not just about Web3, it's also about, traditional businesses, moving off big tech's proprietary infrastructure onto the open public internet. And they're doing it in this case because, those things that I mentioned, smart contracts, smart contract code is tamper-proof, so you don't have to worry about getting hacked or ransomware, unstoppable. You have all these kind of properties like, if you're using it for document management, the date stamps are kind of guaranteed to be true because the system's being run by smart contracts and can't have been tampered with. We've got a Fed Italy recently announced, this sort of supply chain system for verifying things are really made in Italy. And they've got, I think, like 200 auditors that are going to be working with the system already, and they're going to hire another 300. But then I think, partly that's just beginning, but we've already had like Web3 communities building stuff for a while. Like some really interesting social-fi, metaverse, gaming stuff. And I think that, if you look at something like open chat is this thing I talk about far too much, and I'll be transparent. Like I helped put that team together. I wanted to make sure I wanted people to be able to see that you can run a chat service on a blockchain, and a chat message can be processed in the same way as a Bitcoin transaction. Like it can actually happen on chain, and the user experience and everything can come off the blockchain. And then I wanted to make sure that people could see that when you build something like a social network with smart contracts, right, the social network service can have different kind of features and become a completely different animal. Like, your chat account can be a crypto wallet. All of a sudden, if you've got multi-chain stuff like the internet computer, you can send Bitcoin with a chat message. You can totally decentralize it so that it runs under the control of a DAO. And it's not like a DAO on other blockchains. Like, this is one of the problems I'll get to, the challenges we face. Today, when you hear about DAOs, they're not really DAOs outside the internet computer. They're really, with the exception of the first DAO, ironically, in 2016, they're much more like social constructs where people vote on proposals and then someone goes away, and it's just like a text proposal and someone goes away and does it. On the internet computer, DAOs, are different kinds of nervous systems. So you've got a network nervous system that runs the entire network and updates the entire network. All the nodes in the network run under the control of this network nervous system DAO. And then these individual services now are beginning to assign themselves to DAOs. So OpenChat runs under the control of what's known as a service nervous system DAO. All the updates to the software go through that. It's like fully on-chain, end-to-end, and controlled by, decentralized digital governance system, right? And so, that kind of thing is like also demonstrating to the enterprise space, holy cow, like this internet computer thing's real, actually works. Like here you've got a social media service that has thousands and thousands and thousands of users, that provides an extremely sophisticated experience where, people's chat accounts can be crypto wallets, and yet, it runs without a firewall, and this stuff's not getting stolen, right? That's insane, and it's never going down. It's not quite true. I think they did run out of memory on one of the smart contracts once, but generally speaking, it's like very, very reliable. So I think it's so we're looking at like that's why we talk about blockchain singularity. So we want to make sure that in the future, a lot of people, like, maybe they're not getting money from VCs and they're not getting money from maybe people around the world are creating these kind of innovative, genuine Web3 services. We call them open internet services. And, they're going to be doing a decentralization swap to distribute their governance tokens. The funds don't go to the developers. They get held by the community DAO, but the developers get founder governance tokens. That's a new business model. And also, this thing that's being created is got these really big advantages. Like, if you look at OpenChat and where it's going, I mean, it keeps just doing these really fucking cool new things that you could not possibly do unless you're building on the internet computer. So one of the things they're doing too now is because it runs as a protocol, is they're starting to distribute governance tokens, the chat governance tokens to the users have got this diamond thing. And there's some thousands of those that are going to go out. What they're doing is they're going to make the users founders. That's the future, right? In the future, internet services are going to be kind of like community operations, and they're going to make thousands and then millions and maybe one day billions of users into kind of founders in the sense that they're going to get governance tokens, they're going to advocate, they're going to get rewarded for creating content that goes viral, they're going to get rewarded for helping with things like content moderation, and that's just a different kind of thing. And they're going to have all these kind of cool features that you just can't do unless you're running 100% on a blockchain. And then for the enterprise folks, it's like, well, wait a second, right? You can build this kind of thing on a public network out of code that's tamper-proof and unstoppable, and this is our critical infrastructure. We can even control that with a DAO internally and just distribute the governance tokens internally, so you haven't just got one tech guy with a key who could update all the systems. Like, wow, we want to do that too. And that's why we believe in blockchain singularity. It's like, for us, in the end, this is just the same as the battle between AOL, CompuServe, information superhighway idea, and the internet. Humanity will naturally choose to build on the open internet versus big tech, and they would prefer to do that anyway, all things being equal. But in actual fact, blockchain technology just brings these revolutionary, game-changing technical advancements with it, because smart contract code is a completely new kind of software. So I think smart contracts are going to eat software, and blockchain is going to eat cloud. And with our the multi-chain capabilities that the internet computer brings, we're going to all of these things, existing blockchains are going to be part of this world computer. Like Bitcoin will be part of the world computer. Ethereum is going to be part of the world computer, because chain key crypto makes it possible for code on the internet computer to create transactions on Bitcoin or create transactions on Ethereum without having a private key. That's the crazy thing, right? Chain key crypto means that, the internet computer can create public keys, and then the whole blockchain is the private key, if that makes sense. So the blockchain is able to create signatures, and the private key doesn't exist in a way, right? So, that means that all of this, this lots and lots of blockchain can be kind of roped into this internet computer and help create this world computer. And in the end, I'll bet, it doesn't matter whether Divinity fails and we get blown up by the bad guys, like some stupid class action from Avalanche, or that fucking Ray Freeman thing, or the SEC, whoever it is. It doesn't matter. It'll set the cause of world computer back by years and years and years. It'd be a tragedy. But this world computer thing is going to happen. It's absolutely inevitable. Blockchain singularity will happen. Everything is going to run on blockchain. It's just a matter of time. And for me, as a founder of Infinity, I understand my tech history. I just don't want us to be Xerox PARC. Xerox PARC invented the graphical user interface, but it was Apple and Microsoft that made it happen. So my focus is, just pushing through all the difficulties and making sure that the internet computer isn't the next Xerox PARC. The internet computer is the core this world computer that's forming, and that the technology that we spent so long developing and contributing to the network really does power this change, and as soon as possible. And the signs are it's happening. Things are going well.
Mm-hmm. Yeah, Dominic, I want to dive into some of the things that interest me, or at least pique my curiosity that you've broken down. One, and this is something that was shared with me. What is the hashtag bigger than blockchain? What does it mean? And also, you've mentioned several times that the entire Web 2 needs to be protected by firewalls, but that the internet computer does not. And there's a quote, the entire Web 2 can be on smart contracts that don't need to be protected by a firewall. What exactly does that mean for the layman?
Okay, so this is one that it's a challenging thing, right? Explaining the internet was hard enough, and the internet computer is like a whole step even beyond that. So bigger than blockchain, the bigger than blockchain hashtag. I've forgotten about that. Now you've reminded me, I'm going to start sticking tweets again. Thanks. Yeah, the bigger than blockchain is look, basically saying that you've heard all this stuff about what a blockchain is and what it can and can't do, and it's kind of limiting, and it's not true, right? We need to start thinking in more abstract terms about like what is it we're trying to do here? Like, why is a smart contract valuable? Well, a smart contract is valuable because it's tamper-proof, it's unstoppable, it can be autonomous, which means that it's not controlled by a person or a company or something. It can process tokens, all that kind of stuff, right? And if we just for a second stop thinking about the sort of this very limiting view of blockchain that sometimes people promote to make excuses for their very limited blockchain technology, frankly. And if you can just stop, just see beyond that, right? And see a bit more like, how I think about it, which is like, what are the general properties? Oh yeah, tamper-proof, that's pretty valuable. Being unstoppable, that's pretty valuable, right? At that point, it's like, okay, obviously everything should be built with this. Everything should be built with smart contract tech, right? It's just a question of, can you make smart contracts run with efficiency comparable, in the same ballpark as traditional tech? Can you, scale out computation and so on? And those are technical problems, right? But the USP of smart contracts is undeniable. Like, they're a vastly superior way of building systems and services. So when I say bigger than blockchain, it's like we got to move beyond this thing of like it's all just about NFTs or cryptocurrency. Like, this is a battle for the future of computation and how the services that we use every day, that we rely on, are going to work. And all of us spend, these days, increasing amounts of time online. We use services for practical purposes. We use them for fun. We use them for social purposes. Our whole lives are running on these services. So then, if these services are going to be, the sort of the foundations upon which society rests, well, it's very important that we think about how they work, right? And so, I think sometimes blockchain can sort of be self-limiting, which I don't understand. Like, I do understand. Like, people have these very limited blockchains, which can only process tokens or store an NFT, which doesn't even store the data. It's just a link to the data or something like that, right? And so they kind of like constantly say things like, well, blockchain can't scale, it can't do that. This is just part of the deal of blockchain, right? And I'm like, what are you talking about? Like, I've been working full-time, right, blockchain now for I suppose for 10 years, and before that, for another 10 years before that, I've been dealing with distributed computing and crypto and stuff. So cryptography. So that doesn't, that for me, that's just not true, right? So for me, this is about how we re-engineer society, how we rebuild all of these digital systems upon which society rests, right? Even so, we've talked about Web3 a bit, but you think about enterprise. In 21, I think it was, there's this thing called the Colonial Pipeline, which moves oil from Texas to the eastern seaboard of the US, where it goes to refineries and they make gasoline. And it got, all their servers got ransomware, right? So, some all stop working, and if you turned on the screen, it would be like some kind of skull or something with someone saying send some Bitcoin to this address to decrypt the server. So the oil stopped flowing, the refineries ran dry, the gas stations ran dry, and there were these huge tailbacks. People were running out of gas, petrol in English terms. So that's clearly an absolutely absurd way. Like that just shows you can't have like enterprise infrastructure running on traditional data center, server machines or big tech cloud, because it can get hacked, and it can get it's just not a secure way to build the infrastructure that the world depends on. So for me, this is about rebuilding everything. And when you change the foundations of society, and we're increasingly digital, right? There are other sort of second order benefits that accrue. And so, for example, if you look at like this thing that's just emerging on the internet computing now, this service nervous system tech, and the OpenChat was the first. It ran this decentralization sale, decentralization swap, whatever you want to call it. It's running fully on the blockchain, and it's fully tokenized. These chat tokens control it through the service nervous system DAO. That model is important because it's also about like changing the world, the tech economy, and democratizing access. Today, if you're an entrepreneur in Europe, let alone China, say, or God help you if you're in like Africa or something, you can't really raise the venture capital as easily as you can in Silicon Valley. I mean, it's not even comparable. I mean, I lived in Palo Alto for 10 years, so I've got direct experience. And I also was an entrepreneur in London for a long time. And, so we want to make sure that if we democratize access to the tech economy by providing a different economic model where people, for example, can, create prototype services and get something going, and then, decentralize, and then, they don't get it's not an ICO, they don't get the funds, but the funds go into the treasury of the DAO, and they've got some governance tokens which become valuable, et cetera, et cetera. Like, we're enabling people to build successful internet services from anywhere in the world, right? And now if you do that, if you democratize access to tech, ultimately, there's going to be a lot more talent building stuff. And the more talent building stuff, the better and more, innovative and interesting the systems, services, we're going to get to use. And the richer the internet computer ecosystem. So there are also other aspects to this tech. It's much easier, smart contracts are composable, so it's much easier to combine different services on a blockchain than it is to combine different services that are built on traditional server machines and data centers and cloud and so on. So this technology will ultimately change society. Like all of a sudden, you're going to have some team in a country where venture capital was really inaccessible, being able to build the next big thing. So we're making people, but we're also making the communities industrious, right? Because if you look at the OpenChat service, well, and many of these other services that are going to follow, they're going to make their users founders, and they're going to, like OpenChat will probably this time next year, but OpenChat has a team in the hundreds of thousands. Imagine. But it's a virtual team, right? They just made their users founders, and the users are helping with things like creating viral content, content moderation, advocacy. Like that's revolutionary, and that's how Web 3 will take on Web 2. But it's also redefining the internet experience, changing the relationship between users and the services that they use. Providing protections, against state overreach and things like that. So that's what I mean when I say bigger than blockchain. I want people to think much bigger, and that's why I talk about blockchain singularity. It's like, okay, everything's going to run on blockchain, and everything can get re-engineered and made better. So the question is like, what does that look like? How do we get there? And that's what we're about.
Mm-hmm. And Dominic, this is the first time I'm hearing the term blockchain singularity. It's quite interesting, and I wanted to learn more about how Bitcoin is integrated with ICP. Does that mean that we can use Bitcoin on chain? And also, does that mean that we're using wrapped Bitcoin, or is there another version of ICP Bitcoin that people are transacting with? I would love to know more about that.
Yeah. Okay. So first off, to understand the kind of design decisions we make, we have to understand that we're kind of like blockchain maximalists, if that makes sense. And so, I mean, all Bitcoin was, of course, now in technical terms is pretty primitive, but Satoshi introduced a number of lines of thinking which I think remain very relevant and important today when thinking about how to design and evolve something like the internet computer. So at the core of everything he did was this idea of getting rid of intermediaries. Intermediaries are where the problems occur. So and we can see today with the TradFi regulated banks having all these problems. As when there's centralization, the banks are intermediaries, of course. You get problems. You can never really know what's going on, and sooner or later they do bad things. And had the Fed not bailed out Silicon Valley Bank, I mean, you'd have now seen many, many thousands of startups just wrecked across the world. Okay, so when I look at the existing blockchain ecosystem, I'm very frustrated because I feel like a lot of stuff was just thrown together to make quick profits, right? And people created these bridges between blockchains. So, for example, if you're a blockchain like Avalanche, what they did, they create this bridge from Ethereum, and then they just pay some DeFi guys on Ethereum to replicate the copy paste onto the EVM, and bingo, you got a DeFi ecosystem. The token price goes up. But the problem with these bridges is that they are intermediaries. They're centralized intermediaries, and that means they can get hacked. And I forget the numbers, but I think it was in 2022 or 21, $2 billion got hacked from these bridges. Wormhole ETH was a big example. Wormhole connected Ethereum and Solana, and it got hacked for $320 million. And if it hadn't been recollateralized, the entire Solana DeFi ecosystem would have been wiped out. Because, of course, all of a sudden, it's like a poison. People are using wrapped Bitcoin, wrapped Ether, wrapped ERC20, and that is fed into these DeFi systems. And it's a systemic failure. If some of those wrapped coins go to zero, then all of the lending and borrowing breaks and the whole thing just fails. So it's kind of blockchains shouldn't do that. The whole point about blockchain is that not possible, right? And so what happened in the event was that the biggest backer of Solana is, of course, Sam Bankman-Fried and Alameda and FTX and all that kind of stuff. And the other one is Jump Trading crypto. So Jump Trading, and you can get a sense of how much soul they must hold, because they actually recollateralized the Wormhole ETH bridge to prevent this kind of meltdown happening. But that's just no way for a crypto ecosystem to work. So remembering Satoshi's teachings of philosophy, you've got to remove the intermediaries. So the internet computer doesn't believe in bridges, and that's why we've taken a long time to get to where we are in terms of internet computer DeFi. We were refused to create a bridge. We just doesn't fit with blockchain philosophy in our thinking. So we leaned instead on developing this thing called chain key crypto, which is something that powers the internet computer. And chain key crypto is essentially a system in which a blockchain can have a public key, right? Or it can create any number of public keys, as many as it likes. And it can create signatures that match that public key. But there is no private key as such. Instead, lots of nodes in the network have little bits of data. And in collaboration, some subset of all the nodes, doesn't matter which subset, it just has to be sufficiently large, it has to meet a threshold in size, some subset can collaborate to create a signature, okay? And that's how the internet computer scales, because individual subnet blockchains, nothing like Avalanche subnets. Avalanche subnets are really standalone blockchains, and they just use the word subnet because they saw that the internet computer had these subnets, right? Very annoying. But the internet computer has these subnet blockchains which are combined into a single blockchain. And the way this works is that each subnet has its own public key, and when it sends messages to another subnet message being a transaction or a transaction result, it's able to sign it. And of course, it does this efficiently by signing vast numbers at once using kind of Merkleization and so on. But essentially, every single message going back and forth between subnets is signed by the origin subnet. There's this thing called the network nervous system DAO, which controls the entire network. It has its own. It runs on a subnet, for example, and it has its own, public key. And so when it's like instructing node machines, the internet computer runs on these things called node machines, not in the cloud, obviously. And those node machines are kind of like listening to the internet computer's governance system, the network nervous system, and it sees these instructions coming through and they're signed, right? So that's how the internet computer scales, and the individual subnets are able to trust each other's messages without seeing their blocks, right? Because they can see the signature on they can see they're signed. We took there's a lot of very complex protocol math involved in making that work. But we built on that and we created an adaptation for threshold ECDSA. And we'll do other ones later for like Schnorr and so on. So that meant once we did that, we could, and that got, adopted by the network. Smart contracts on the internet computer gained the ability to say, give me public keys, right? And I want to create a signature for those public keys. So that public key could be a Bitcoin address, for example. Now, Bitcoin is a special case. It's kind of a complex network. So you've got these or more of a complex model. So you've got these thing called UTXOs. So coins kind of exist separately, and they kind of are moved around in transactions. So we wanted to make that easier for smart contract developers to interface with. So we created APIs that make it very simple for a smart contract to say, give me a Bitcoin address, send Bitcoin, and so on. And then the internet computer nodes actually talk directly to Bitcoin nodes. So internet computer nodes talk directly to Bitcoin nodes, and which is great. Obviously, it means you don't have a bridge or anything like that. There's just like network to network. Obviously, you're exposed to the security of two networks, the internet computer and the Bitcoin network. So you are losing a bit of security, but it's very different to having a trusted bridge, like some intermediary that's forwarding stuff back and forth. And so today, a smart contract on the internet computer can, create, addresses on the Bitcoin network and send and receive Bitcoin. And, the Bitcoin moves on the Bitcoin network, and there's no wrapping or anything like that. It's just purely, pure crypto without intermediaries, which is very, very cool. Now, that's already happening today. That can be done. The only thing, of course, at the moment with that is, Bitcoin's quite slow. It takes about 40 minutes or something really to, in expectation, can take longer, sometimes less. It takes that long to securely, to know that a Bitcoin transaction's completed. And whereas the internet computer is by design very, very fast, and it has a finality. Smart contracts can update. Do these update transactions in 1 or 2 seconds. So there's a thing called chain key Bitcoin, right? And chain key Bitcoin is like an autonomous smart contract, which actually can be updated by the network nervous system DAO. And this basically will give you a digital twin. So you just send Bitcoin to this chain key Bitcoin thing. It's a bit like a layer 2. It's kind of, there's no real analog, to be honest, today in crypto, but you can think of it a bit like a layer 2. And you send your Bitcoin in and you get like a digital twin, which is chain key crypto. And that you can move that around incredibly inexpensively with 1 or 2 seconds finality. And then when you're done with your chain key Bitcoin, you can turn it back into Bitcoin, again, without a trusted intermediary. So everyone was waiting to use this chain key Bitcoin, and the network hasn't fully turned it on, okay? Even though it's all working, it's all been built. And the reason for that was very simple, which we didn't anticipate to begin with, which is that, some Bitcoin is what you call, because Bitcoin traces individual coins, as opposed to Ethereum where everything's just in these balances, right? On Bitcoin, you can trace these individual coins. Because of that, some Bitcoin is what's known as tainted Bitcoin, like it's been through Tornado Cash, or it's related to some hack or something like that. And the exchanges won't touch tainted Bitcoin, right? So what we became worried about was that people would, check their Bitcoin into the smart contract, check tainted Bitcoin into the smart contract, and then somebody else would stop using the digital twin chain key Bitcoin and get the real Bitcoin, but they'd somehow received this tainted Bitcoin and they wouldn't be able to send it to an exchange. So what we're doing now is we're talking to people that provide, this kind of chain analysis stuff that will provide an API that specifies what's Bitcoin's tainted. But of course, we have to do this in a decentralized way, right? So this is the difficult bit. So smart contracts on the internet computer can also call out using something called HTTPS out calls that go through consensus. So we're trying to negotiate like an arrangement where I say, look, you guys, we'll put a proposal in to the DAO that says, look, if you accept, then you're going to provide like an API for this smart contract, because the smart contract can call out, right? On the internet computer, you can call out from Web 3 into Web 2 if you like, and that the DAO will pay you. The DAO itself will pay you, right? So it's, we maintain this decentralization property that's so important to us. And I think I haven't had a chance to keep up with it, but I think that is going fairly well. And so hopefully a proposal will go in, in the next couple of weeks or something. And some of these chain analysis type people will provide a service to the smart contracts and get paid by the DAO. But that's obviously a new kind of arrangement. I mean, normally blockchains are really kind of centralized, and this blockchain is very decentralized, and not only by design but by philosophy. So yeah, that's where we are at that. But yeah, and it's a big deal. And also that same thing that was done with Bitcoin is the similar kind of work's being done with Ethereum now. So you get this, like, smart contracts will already have Bitcoin APIs, they'll have Ethereum APIs, and they'll be able to invoke Ethereum smart contracts and move around ETH and ERC20 tokens. But if you want to use the user experience, you can actually do it today, because there's another API that just allows you to, create public keys and then sign for them. So for example, somebody, if you have a smart contract on the internet computer, if you wanted, you could create a public key for the Solana network, and then you could manually construct the Solana transaction, sign it using these APIs. But because the networks aren't integrated, you'd have to forward the signed transaction via the user experience. But that's actually possible today, and there are a lot of people in internet computer DeFi now experimenting with this technology. And I think there's a thing called ICDex.io. Who's heard about that? IC for internet computer, Dex, DEX.io. It's a team of like 20 people in Shanghai, and it's a DEX that looks, it's an order book exchange, right? And that's going to pretty much list every crypto asset on Earth once this stuff gets going. It's going to be insane. And again, same thing, no bridges or anything like that. It's just going to be the smart contract that creates that exchange. Just if you go to icdex.io, it doesn't use a friendly URL yet. It redirects to this kind of crazy looking URL, which is the smart contract's underlying address. And the user experience is created by the smart contract. And soon it's going to, because of this chain key technology, it's going to make all the crypto assets in the world tradable on a proper order book exchange, which will be controlled itself by a DAO, so that the devs behind it can't run off with all the crypto that it's controlling. Yeah.
Well, you answered my follow-up question, because I love Bitcoin and I love Ethereum, and I think it's awesome that you guys are working with Bitcoin and Ethereum, unlike some other, especially other layer ones back in the day that deemed themselves as Ethereum killers. I think that to reach that goal of blockchain singularity, you guys are on the right path. At least that's what it seems like based on what you've shared with us today. Dominic, you talked at the very beginning of the space about how you once built your own MMORPG, or maybe it was an MMO. I can't remember, but it's my. Is this an MMO?
Yeah.
Well, yeah. MMORPGs are my favorite genre of video game, but MMO, very cool. I love it. I'm a big gamer, and I really am looking forward to the future of Web3 gaming once it's done right. And I would love to know, with respect to Web3 gaming and NFTs, how do you see all of that fitting into the ICP vision?
Well, Well, look, I can't say too much, unfortunately, because it's the nature of it. So there's a huge project. I think people have heard the name Dragons, which is being developed by a real genius who's got Form. He previously created something which had more than 100, ended up with more than 100 million users. He was also sort of one of the kind of big old crypto whales behind the scene as well, and ETH, very early in ETH and so on. And that's been worked on. I've got a lot of faith in that. I'm really excited. I've seen it, and it's a shame it's developing in stealth because I'm super, super excited. So there's like, at the moment, big games being developed that you can't see yet, but it's not like the sort of flywheel BS stuff that you see on other blockchains where, FTX Ventures puts in some money, Solana Labs puts in some money, Alameda Research puts in some money, some other vassals and proxies of Sam and that kind of thing put in some money. And then it goes to like the big VCs in the valley and they put in some other money and everyone goes, hurrah, this is the future. Like, games are a tricky thing. To make a hit game is really difficult. As I found out, right? I certainly wanted a lot more than 3 million users, but I think I did all right. It's the only game I've created, and it was pretty cool and innovative. It's like no other game there. Very strange game, but it's had a cult following. You can find it on change.org. There's like a Fight My Monster petition demanding I bring it back. I think so. But talent is a big thing, and often to develop something really exciting it takes years. So that's happening now on the internet computer. I think people will see the fruits of it and soon enough. So the question is like, what form does Web3 gaming take? And we've all seen Axie Infinity. And I think that was like an early demonstration of the power of play to earn. But again, I just think that's an early manifestation. I think we're going to see much more sophisticated manifestations. And it's a, blockchain singularity is a bit like an event horizon. You can't really see what's beyond because it's difficult to anticipate all the different ways these things will work. But I'll give you an example of just completely random, like something that I believe in. I kind of like that project Cubetopia. And Cubetopia is this kind of game. I haven't looked at it for a while, but essentially the idea is that everyone gets their own island, right? And it's like a Minecraft world. And straight away, people will tell you, like a VC will tell you, well, everyone loves Minecraft. Why would anyone play Cubetopia, kind of thing? So I'll tell you why they will. So, or at least, if that project plays its cards right and keeps going. The idea is everyone creates their own like island, right? Which is like a Minecraft style island. And then you basically share the URL to your own island, which is on the blockchain, it runs on the blockchain. You share the URL in your Twitter profile. So it's going to be like, I have that on my Twitter profile. You want to come and talk to me and you just click on that and you can walk around the island I've created and maybe you'll find me and you can have a chat kind of thing. Obviously, now you've got the very simple applications of NFTs there that most people don't have time to build a castle for their island, right? So you can imagine going to like a marketplace where people have like, constructed like castles and like, here's this castle and there's only 5 of them and this is the price and you can buy it and now you can just import it into your island and by doing that kind of thing, you can make a really cool island. But okay, then that's the basic thing. Now, let's imagine that you had some functionality so that people can create like a casino or something, right? So these cubes, you could go into a casino and maybe like the fruit machine, the one-armed bandit kind of things on the side of the cubes, or maybe you click on it and it pops open in an iframe over the kind of Unity thing, which is now running WebAssembly over the top, and it's more like a web sort of box over the top. Whatever, right? The point is somebody creates a casino on an island. Okay, cool. So now you've got this problem, like how do you get people onto your island, okay? And get people so they can come play the casino. Okay, so now imagine, let's just say I've invested lots of time in my Cubetopia island and I've got loads of footfall, loads of people inside this island. And this other person has got like this island that doesn't have many people, right? But they have all this casino, they built all this casino stuff and they want to get people to their island. Okay, so imagine now there's an NFT that's really a portal that will take you from one island to another island. Okay, so I could like say, right, I'm going to create 10 of these portals on my island, only 10. And you can buy an NFT month by month. So like, you know, we're about to hit April and somebody could buy one of these portals for April and they can configure which island it takes you to. So the guy with the casino island, he buys one of my portal NFTs, right? Like teleporting NFTs, right? And that, let's say, you know, I've made a castle and as you go into the main hall of my castle, everyone always goes there. On the side, there's like this teleporter, right? And there's a doorway and it's got some sort of cool sign of the casino above it. And now people who are on my island, they go to the castle, they go into the hallway. And then on the right, there's a doorway, right, with the casino sign. And you walk through that and bingo, you're right in, now you sort of land, you know, a bit like, oh God, what's that game where everyone does the silly dances? My brain blank. What's that called?
Fortnite?
Fortnite, yeah, there you go. Fortnite. You know, when you come into Fortnite, you sort of land with a kind of parasol kind of thing. Right? So now, like, people come to my island, they go into the castle, they go into the hallway, and then there's like the doorway on the side with the casino thing. You go through that, and now you land on the parasol, whatever it is, right? You land on the casino island. Okay, so now the guy's bought this NFT, which is a teleporter, and traffic from my island is coming to the casino island. And of course, he could replicate that over and over again with lots and lots of other islands. And all of a sudden, now his casino island has got, you know, big footfall, lots of people walking around. Very, very cool. Now, you can draw an analogy between that and the way the internet works, right? The internet is a decentralized system. It doesn't work with tokens. It works with peering relationships. So, right, if you have like a Wi-Fi router, that's a subnet. And you pay the ISP to peer your subnet with their subnet. And then that ISP is paying like Global Crossing or Level 3 or Cogent, whatever, to peer, to peer their subnet with backbone providers and so on and so forth, right? So that's how the whole internet works. And now you've got this crazy, that's what Cubetopia could be, right? This crazy Web3 world where everyone's creating their own islands and people able to create this economy through NFTs that teleport you from one island to another, but that's almost like peering relationships on the internet, right? So I think there's going to be lots of stuff like that where completely new ways of monetizing attention and content appear, and they're going to look very different to what we see today. I think the blockchain singularity thing is like an event horizon. We can get little kind of insights like that. And, wow, that would be cool, right? Yeah, sure. Look, if I've built up my island and I invested all this time and effort into making it cool and making money, if I was buying castles ready-made and all that stuff as NFTs, why? And I've got these people on my island. Like, why wouldn't I sell some NFTs myself? Just sell some of these portals that take people to other islands, right? And then that's going to result in these kind of new kind of economies. And I think the games of the future will, comes back to that thing of with social media, like that open chat thing, making the users founders. Like the objective is to one day get to billions of users, but do that by making, the first few million users into founders, right? But also making anyone who uses it part of the team, like this giant industrious virtual team, because they can get rewarded for creating viral content or helping with content moderation. That same kind of thing is going to exist in the metaverse and in games, the creator economy, and but it's not necessarily going to. People will get rewarded for helping with things like content moderation, like someone's creating an avatar and it really looks like a nude woman or something like that. Like, who's going to check up on that? Or this one's got this person's created an avatar that's got like a Nazi, there's a swastika or whatever. Like, there needs to be, these virtual worlds are going to need content moderation, right? So and these virtual worlds of games are going to reward people for content creation, content moderation. But as per this kind of example where people can sell peering relationships between different virtual worlds that people control, it's not the economic models of tomorrow. I think are going to be radically different. But it's difficult to predict all of the ways they're going to be radically different because, human ingenuity is a crazy thing. So once this thing gets momentum and there are thousands and thousands of people sitting there thinking, how can we innovate and find new ways to, create community-driven growth and business models and so on in a decentralized setting, right, where there's maybe no company everything's controlled by DAOs and all that kind of stuff. We're going to see some really interesting new things, and it's difficult to predict. But one thing we can be sure of is that it will be kind of transformative. It'll just create a completely new, much more immersive, much richer internet environment that should also be hopefully fairer.
Hopefully, and this is the sector of the industry that excites me most, and I love listening to you break it down in your own words and break it down with your own vision as like a kid in a candy shop. It was really, really fun to listen in on that. We have 5 more minutes. I know you have a hard stop here, and I have a couple avid community members that have questions, so I'm going to pass the mic.
Cool.
Dominic, and then I'll
Sure.
circle back. Aisha, go for it. Aisha, you there?
I think she's on mute.
Yeah, she might be having connection issues. Captain Levi, you there?
All right.
Hello.
Can you guys hear me?
Yes, I can. I can hear you both. Aisha, mic's yours, and then I'll go to Captain Levi after.
Okay. So it seems that many developments in the fields of cryptography and distributed computing were necessary to create the world's first real global computer. I'm interested in knowing whether your organization has secured patents for the pioneering technologies employed in this project, such as your unique consensus model, chain key cryptography, heartbeats, and concurrent execution.
Haha, that's a good question. It's a thorny question, right? Because we all believe in a totally open world. So I can tell you that we do have some patents, and however, they're licensed for unlimited use within the internet computer ecosystem. So, and that's non-revocable, right? So all of the cryptography and protocol math and everything else, virtual machine innovations and whatever else, they're all any IP that we've developed is free to use within the internet computer ecosystem. The reason that we took these patents is, one, is defensive. It protects the users of the internet computer from somebody later on claiming the invention and trying to level lawsuits at the people who run these node machines. That's a big reason. There is actually, another thing that we never really thought of originally, but we're sort of exploring now, which is that potentially the Dfinity Foundation, which is a not-for-profit, by the way. So Dfinity is what's known as a stiftung. A stiftung's like, we're based in Zurich, Switzerland. It's like a German word for foundation, and a foundation basically just has a purpose. So there's no partners, there's no members, there's no stockholders. So all the money that's in the foundation is basically just spent on our purpose, which is number one, research and development of internet computer technology that can be used by the internet computer public network, and number two, advocating for the ecosystem. And arguably, we've not done as well as the R&D, but anyway, that's another purpose, right? So, we do have these patents, and so our objective is to get funds in, and the more funds we have, we just spend it on R&D, right? So it's good for everybody. Doesn't go to us, doesn't go to me. The thought there is that we could license the technology of the internet computer for things like, creating unstoppable compute systems. So there are actually a lot of specialized, applications like defense and things like that, where people want the ability to create compute platforms that can't suddenly get encrypted with ransomware. Can you imagine on a battlefield, you're a soldier connected to some compute platform? It's like you got like some head-up display unit or something, and all of a sudden it just gets replaced by the sort of laughing Turk saying, haha, you've been ransomware, send some Bitcoin to this address, and you can get it going again. So there's actually we believe that quite a big market within like these specialized areas where people might want to use that technology to create unstoppable, unhackable, unstoppable compute platforms. So, for example, those patents that would allow the Dfinity Foundation to license that technology, and then with the funds, and that's an active, I can't tell too much, but that's an active line of inquiry, and take those funds, and then the more funds we have, the more R&D we can do. We're about, I think we're on the way to 300 people, but shrunk a little bit, but It sounds like a lot of people, and a lot of our people are, highly paid, like super elite engineers, cryptographers, computer science researchers, and so on. It's a pretty technically challenging field, and it costs a lot of money, even with on the way to 300 people. But we'd like to scale up to thousands of people, and we just can't afford that at the moment, right? So either crypto prices have to go up, or we have to find additional lines of revenue. So the answer is, within the internet computer ecosystem, any technology that's being used is licensed irrevocably for eternal use, right? And all the code is open source. Anybody can do what they like with it. We have patents on some of the stuff, I think like 10 or 11 or something like that. But the purpose is, number one, defensive, to prevent people who use the internet computer suddenly finding some troll project coming along and trying to sue them. And secondly, we're now seeing that maybe, we could license it and bring more money in. And remember, it's not Definity Foundation is a not-for-profit, doesn't have any members, doesn't have any partners, doesn't have any stockholders. All the money it collects just gets sent straight back into the ecosystem, because ultimately we're gonna spend it in pursuit of the purpose. I'm just going to spend it on R&D or give it away in grants or whatever it is. But the answer is yes, we do have some patents.
Okay, thanks for the detailed answer. One more question I would like to ask. Considering that the internet computer is being hailed as the future of blockchain technology, I'm curious about whether internet computer is protected against quantum computing threats.
Good question. So there are a number of things here. Like the first question is, how far away are quantum computers? And you'll get some very different answers from different people. We speak to a lot of senior cryptographers and people in the quantum space, and we believe it's actually some number of years away, right? We're some number of years away from a place where people have these general purpose quantum computers that they can use to crack crypto. And so we keep a very close ear to the ground and watch developments very carefully, because we don't want to be caught out, obviously. Within that context, we are sort of doing a limited amount of research into quantum safe computing. And we also are sort of loosely collaborating with an organization in America that's specializing in quantum, post-quantum safety and so on. So, we are sort of, I guess, hedging our bets. On the one hand, I think that the threat and the risk is greatly overstated. On the other hand, we don't want to be caught out, so we're kind of hedging our bets and carefully moving into the space and without diverting too many resources, beginning to collaborate with outside actors and do a bit of work and thinking internally. The last point is that the solution to quantum computers, if and when they arise, is partly going to lie with quantum safe cryptography, but not always. There are other things that you can use in the design of crypto systems that can also work. So, I don't know if you've ever heard of a thing called a verifiable delay function and things like that. There's timing. If you have a network of nodes, the communication between those nodes, the time that it takes to send a message from one to another is limited by the speed of light. Once all networks are fiber, and in practice, even more limited than that, because you've got these relays between the different links. So, there are other things that you can use, and there's also, of course, the speed at which even a quantum computer can break certain kinds of crypto. And so, the point being is, I think there's the debate's still open. I think the solution to quantum computers, general purpose quantum computers, if and when they exist, will lie in a variety of techniques. And of course, quantum safe cryptography will be part of that.
Understood. Thanks for making me understand. Thank you so much for answering.
No problem. Thanks.
Hey, Captain Levi, you got a quick question, sir?
I have about 2 or 3 questions. The first one I actually heard was the statement you said during the AMA. You actually made mention of the fact that multiple public keys can be generated. I already understand the concept that public keys do not really warrant serious security issues, but I wanted asking, at some point, are these public keys going to be revoked when they are not in use? Is there a certain timeline when these public keys become revoked?
That's a really good question. And to my shame, I can't give you an immediate answer, just because I've been sort of dealing with so many different things. So I haven't gone to that level. I think at the moment, they're probably non-revocable. They're not very large. I mean, the thing is, don't forget, when you create a key pair, you have to pay for it, right? So, and you pay for it with gas. It's called cycles on the internet computer. So it's not like we're giving these things out for free. And actually, the native chain key crypto of the internet computer is pretty damn efficient. But the threshold ECDSA chain key crypto that people use to create, public keys on other blockchains and sign transactions with other blockchains and so on, that's much less efficient. And for that reason, I forget, each subnet can only produce a few of these things every second. And so I think for that reason, it's not, it's pretty inexpensive, but it's not free. So I think, if there were too many of these things being created, the price of creating them would just be the government. The network runs under the control of this thing called the network nervous system, which is like a DAO, but something that's a little bit more sophisticated, well, a lot more sophisticated than any kind of DAO you may have seen before. That thing would be able to adapt the network and increase the cost of creating these things if it turned out to be a problem. But I think what you're asking is, can somebody just spam the network creating so many of these keys that we're forced in either to maintain a very large number of redundant keys or to start timing out keys that are no longer being used. But I think that would never happen. Like, if a smart contract has created a key pair, the key pair would never disappear. However, remember that smart contracts on the internet computer have to be fueled with gas or cycles in order to run. And if they run out of cycles, if they're not given more cycles, after about 3 months, they disappear, right? They self-delete. Now, that in normal circumstances is not a problem, because say, for example, you've got like a DeFi smart contract that can't be updated by anybody, but lots of people are using it, and it runs out of cycles. Well, one of the people using it are going to send some more cycles to it to ensure it continues running. Where this would be a problem is if somebody had a standalone wallet contract, right? And that standalone wallet contract created a bunch of keys that were being used on other blockchains. In that case, the user if the user was self-managing that wallet contract, they'd need to make sure it was charged up with cycles. If it ran out of cycles and they went on holiday for 3 months and came back, it could disappear, right? Obviously, in practice, the cost of running a smart contract, keeping a smart contract on the internet computer is tiny, so most people would make sure that there's enough crypto to keep it going for hundreds of years. It wouldn't be expensive. But that kind of issue can be avoided by having like wallet smart contracts that are run by a DAO, and that DAO will make sure that something like that can never happen. By the way, something people listening might want to check out, there's a thing called the Me Plus wallet. It's created by a team called Astrax in China, and they're inspired by WeChat. And they've created a bunch of things and some very interesting stuff coming out of that lab. But the Me Plus wallet is one of them. And it's a multi-chain wallet. So actually, the Me Plus wallet runs on the internet computer. It's created by an internet computer smart, or the backend is an internet computer smart contract. But you can keep crypto in the wallet on, a very large number of blockchains. And the only caveat I'd say at the moment is that's not controlled by a DAO yet. And that means the developers probably get some. They're completely honest and brilliant people, but it's not quite the same as a service that's running on the control of a DAO. But in that circumstance, obviously, you've got like a service, right, that's run by a DAO, once they've assigned it to a DAO, which they need to. And therefore, that DAO provides the security, and the DAO is making sure that, that the smart contracts are always fueled with cycles and aren't going to disappear. But again, there's a new thing called wallet apps where you actually run these services yourself, if you like. On the internet computer, there's something that's emerging at the moment. You could do that with a wallet, but you'd probably be wise just to pre-charge it with cycles that last you, 100 years, so you don't have to worry about it. Does that make sense?
Yes, it actually does make a lot of sense. I was actually thinking of a simple solution, but with the way you presented it, it's actually even much better than what I had in mind, because what I actually had in mind was the fact that after a certain period of time, those keys actually self-destruct. But you actually propose a better solution to the problem. My final question is concerning your developer tools. These tools, are they actually open source, and are they patch edits, and are there pull requests to be an improvement made to these tools that are actually placed on your website?
Yeah, so actually, I don't know how technical you are, but just something I thought I'm going to go and investigate myself. So, really the keys, when you create keys, the keys belong to a smart contract, right? So if the smart contract disappears, well, you wouldn't be able to access those keys. However, what I don't know, and I can't tell you, is whether when the smart contract disappears, the underlying crypto on the nodes that maintains the keys that the smart contract owns disappears. I'd have to imagine it does, but that's something you should post on the forum. It's an interesting technical question. So the other question, sorry, was, again, my brain got fixated on that first one. Oh, developer tools.
Okay.
Yeah, the developer tools. Right, no, I heard it. Yeah, developer tools. Yeah, we definitely want to help with that. We recognize the developer tools could be greatly improved, and we would love community members to submit pull requests. By the way, if you go to the internetcomputer.org website, that website actually runs, first of all, on the internet computer. It's actually hosted on the internet computer. Secondly, somewhere on that website, there's an edit button, and I've asked to make it more obvious, but community members can also submit pull requests to the website. Like, it's on GitHub, and you can submit pull requests. I should say on GitHub for now, because someone on the internet computer is creating this thing called Codebase, which is like a decentralized GitHub, which, of course, I think everyone in the space should move over to as soon as it's ready. Codebase.org or something, it's at. But at the moment, yeah, the source code's still on GitHub.
All right, that actually sounds good. I do have other questions, but I'll need to probably align my train of thoughts. Maybe I'll be asking them in your groups. I really appreciate your detailed answers to my questions. I think ICP is something very unique. Wish you guys the very best, and I hope Internet Computer Protocol stays bullish moonward. Thanks a lot, Noah. Over to you.
No problem. Thanks.
Thank you, Captain Levi. Rahmat, do you have one high-level question? I know Dominic is over his hard stop time, and it's been a pleasure.
I'm good, actually. I've got a bit of leeway, actually, before this next meeting, so I'm good. We can give it about 5 minutes.
Rahmat, go for it. Rahmat, you there?
It's the mute button problem.
Yeah.
Yeah. Can you hear me?
Yes, sir.
Can you hear me, guys?
Yeah, Rahmat.
I can hear you. Yeah, I can hear you.
Yeah, okay. I have one question. So I've read in a Medium article that proof of useful work consensus algorithm involves blockchain produced by dedicated hardware called node machines with similar standardization computational specifications. So I'm curious whether clients have the option to construct their own node machines that satisfy the necessary specification, or if they must procure specialized equipment from Dfinity to become a node operator.
Yeah, just to be clear, I mean, Dfinity doesn't produce any equipment itself. So I think so first of all, for those listeners who aren't aware, we kind of a lot of what we do is kind of informed in many ways by sort of original learnings from Satoshi. And, we believe that blockchains should run on sovereign networks. Bitcoin runs, the blocks of Bitcoin are created by miners who are running this hardware that does hashing, okay? We like that kind of architecture, albeit Bitcoin proof of work as used by Bitcoin combines two different functions, Sybil resistance and consensus. And you actually need to separate those out if you want to have a performant network. So on the internet computer, really participation is by way of running a node machine. Now, of course, as per Bitcoin, like it costs you money to buy an ASIC, right, to do hashing, and it costs you money to buy a node machine. They're about 20 grand at the moment, and then you're gonna you got to put it in a data center. You're gonna get co-location contracts, bandwidth, all that kind of stuff. So, people make an investment in the hardware. They're investing, if you like, in participating by way of liquid hardware rather than by stake. And on the internet computer, really, that's just how you participate. And the network nervous system is a further level that mediates it because it inducts nodes based on capacity requirements, all kinds of other stuff, and also combines nodes from different providers to a network and using something called deterministic decentralization. So, proof of useful work is a system where nodes are combined into subnet blockchains from different providers, so you get the right Nakamoto coefficient by the network nervous system. And they need to have, a blockchain replicates computational data. So if you want to have an efficient network where you can maximize hardware utilization, you need all the nodes to basically have the same hardware spec. That's why there's a public spec for hardware nodes, for these node machines. And actually the network can have different generations of specs, and I think there are two or three specs in existence already, and you can build to these different specs. The thing is, the network nervous system can only combine node machines that have been built to the same spec, right? Because in proof of useful work, instead of nodes competing to do the most work, if you like, and outcompete, do more hashing, right? So they can find more puzzle solutions in the form of these by spinning the nonce, so the hash of the block has the most leading zeros, gets past the difficulty, and you can instead of competing in proof of useful work, these nodes are required not to statistically deviate, right? And sans any mitigating factors, which means that they should all produce the same number of blocks. They all need to keep up with the tip of the chain, right? And if your node doesn't keep up, then it's statistically deviating, and the network's governance system, the network nervous system, can, to use common parlance, slash it, right? So the way to, if you built a node to a below the spec, right, and then you add it to a subnet that was under load, heavy load. Like if your node machine didn't have the same hardware as the other nodes, it might fall behind. And it would thus statistically deviate because it couldn't produce blocks when the random beacon told it to, and it would produce less blocks than the others, statistically deviate, and could be slashed. So that's why the node machines are built to these standard specs. And obviously, you wouldn't want to build something that was had better hardware than the standard spec, because the random beacon is going to ask you to do the same work as everybody else, so you're not going to get an economic advantage. But you certainly wouldn't want to have a node machine that had was built, had hardware that wasn't matching the spec. So anybody can build. You can get hold of that spec and you can build the node machine yourself. I think we made it easy for people by finding suppliers who will build you machines to the standard specs. But that we have, just to be absolutely transparent, we make not a penny from that. We don't have any kind of commercial agreements with people that will make you these. It's just purely as we just identified this as a convenience for the node providing community, and people are completely free to build their own node machines, or even if they want, build node machines to these specs and sell them to node providers. Like, it's a open public network. It's permissionless, right? You can do whatever you like. Only caveat being, of course, if you're selling a node machine that meets a spec, and if that hardware isn't meeting the spec, it could result in the node being knocked off the network. But anybody can build the machines for node providers. A node provider can build their own machine, or they can buy it off one of these people that will sell you a ready-made machine.
Got it. Thank you so much for the clarification. Over to you, Noah.
Thank you, Rahmad. Motivelli, last but not least, sir. Mike's yours.
Hey, Noah. Hey, everybody. Dom, super insightful. I was listening and just really soaking it all in because I'm a believer of the world computer. I'm just not sure what's going to happen. So I guess I had a really quick question for you. So in your mind, are DAOs critical to the success of the world computer? That's my first question. And then my second question is like, what keeps you up at night with all of this? Like what thing do you think is true that might not be true?
Well, yeah, I mean, so first of all, with respect to DAOs, look, it's absolutely central to the world computer vision. And if you sort of rewind to 2016, you'll see I was one of those people that were very worried about the DAO, and I was talking about various security flaws in its design. And, there were sort of game theoretic attacks like ambush voting and things like that were possible with that design. As it happened, it was just, it was a reentrancy bug that brought it down. And reentrancy is an issue on all the EVM-based blockchains. But so much so that people thought I was even accused of being the DAO hacker myself. I can promise you I wasn't. And then after that, I think it was, either in late 2016 or early 2017, I proposed something called the blockchain nervous system. And that was, I actually messed around with a guy called Gustav Simonson back in the day, messed around with Ethereum code base and just created like a smart contract that had access to a privileged opcode. Only the smart contract could access that privileged opcode, and we showed how you could do some management functions by this smart contract. Just you could do this very simply on Ethereum already. And okay, so since you can do that, then why don't we create a blockchain nervous system, a much more sophisticated DAO that doesn't have the kind of vulnerabilities of some of these basic designs that would be sort of fully automated, right? So today, like if you look at that, like what's the ApeCoin or something? I went to check this out. It's a big DAO with this governance token. It's worth so much money. What's inside this ApeCoin thing? And I just saw it as this thing where people just posting these like textual proposals, and then the idea if one of them gets enough vote, like the devs or the company that's running this thing go away and implement it. It's like, well, that's not our vision, right? Our vision for a DAO is a digital governance system that actually directly controls something, not something where people have to obey its commands, but it executes, it exerts control directly, right? Again, same old thing. Satoshi philosophy, get rid of intermediaries. So we wanted a blockchain that could run under the control of a very sophisticated DAO. And it's called the network nervous system because of the way the governance works, where people stake ICP to create voting neurons, and voting neurons can vote automatically by following other neurons, right? That's what it's called, the network nervous system. But for example, that thing will instruct, it'll get node machines in the network and form them together into a subnet blockchain, or it will actually push updates to the protocol, i.e., the changes in the replica stroke client software onto these node machines. These node machines will see the instruction from the network nervous system, actually upgrade the logic that they run. So the entire network, there's no idea like, the traditional blockchain, there's like a cabal of insiders, it's like the company, like for example, Solana, right? Every time it goes wrong, Solana Labs basically looks at the blockchain and says, right, it forked here, we're going to rewind to here, we want everyone to apply the software patch. And they sort of contact all the main people running the validators on Amazon Web Services and Google Cloud and Hetzner and places like that. Hetzner closed them down, but that it's like most blockchains today, these proof of stake blockchains are really cloud blockchains, right? They don't have a sovereign network, they run on the cloud. So they contact, they're a central party that go and contact all the people running these validators on the cloud and then get them to update it and do all these configurations and fix the database and just get it going again. That's not what obviously someone like me believes in. So we believe in, blockchain being autonomous, like an autonomous thing that runs itself. So the network nervous system controls the internet computer blockchain, and there's no forking. People since the network's been running, it's processed hundreds of proposals, and they're executed automatically by the DAO, by the network, as part of the protocol. So that's our vision for a DAO, is something that's much more sophisticated in terms of how it works, how the governance system actually works, and also exercises direct control without intermediary. Now, we also believe that this model is the way forward for internet services generally, right? So there's a thing called the Service Nervous System DAO, and it's a brand new tech. It's been under development for quite a long time at this point. It took us much longer than we thought to propose that update to the network. And the first open internet service came into existence a couple of weeks ago. So I've got Open Chat, and basically that thing, Open Chat, that really complex, sophisticated social fi service. It's like a messaging app, but it's much more, because each account is a crypto wallet and all that kind of stuff. And you can send crypto chat messages, and you've got crazy public groups and et cetera, et cetera. That thing is now running under the control of a Service Nervous System DAO. And they made their first update to that system pretty recently, and that's absolutely revolutionary. So, but there's no shortcut, and I think with respect to regulate, the regulatory changes that are coming down, what we want to see is that these Web3 services run like blockchains as protocols, right? That they should be built end to end on the blockchain. They should run end to end on the blockchain, and they need to be controlled by these Service Nervous System DAOs that are capable of helping the community reach good decisions, but when the community adopts a proposal that, for example, to update the software, that is automatically, the DAO takes care of it. It's not like a human being, because if there's a human being, if there's an admin backdoor and all that kind of stuff, well, that's how the problems occur, right? You get rid of the intermediaries. So, the use of DAOs is absolutely integral to the internet computer world computer vision. It's about decentralizing control, but doing it in a way that's very practical. And by the way, I think that the enterprise is also going to move to DAOs, because if you've got a great big enterprise infrastructure running on the internet computer, do you really want just one IT admin having the key and they can just delete it all or configure it or do something bad? No way. You're going to create a DAO, a Service Nervous System DAO, and you're going to distribute the governance tokens to people inside the organization. Maybe not as Open Chat maybe will probably have one day millions of holders of the chat governance token. Inside an enterprise, you probably end up with 20 people. But still, you decentralize control because it makes it more secure and more transparent. So I think, DAOs are integral. Here's a prediction. I think in 5 years, and I could be over-optimistic, I do think in 5 years, most internet startups aren't going to be traditional venture-funded companies. They're going to be something like Open Chat, right? Because just because of the numbers involved, if this takes on in places like China and India, people are suddenly going to realize, well, I've got the talent, I'm willing to work freaking 16 hours a day, 7 days a week. And I want to create the next mass market thing, or I want to do this. So, and I don't need venture capital, because I can get together with my friends, get something going, decentralize it by having a Service Nervous System DAO take over, and it can raise funds from the internet, right? And they don't come to us, but that thing becomes valuable, and we got a share of the, we get some founder governance tokens, right? And I think, look, I've been a startup entrepreneur for many, many years, since really 1991 or something, and on and off, and companies, traditional companies, and other forms of governmental organization are incredibly bureaucratic and inefficient and problematic. You create a limited company or something, you've got to file accounts every year. That means you have to hire an accountant. There's all these different bureaucratic problems and things that you have to do. It's like a huge overhead. In the future, you're going to get much looser groupings of people, not a company. You're going to get community developers that create some crazy Web3 service. They're going to run a decentralization process where a Service Nervous System DAO takes over, runs a decentralization sale to distribute the governance tokens, and it's just going to be a totally different thing. I think most startups are going to be DAOs, right? And it's not going to be that. It's not that. I mean, it's difficult to see it in this crazy crypto winter, right? Which is a really bad one. But that's what I believe. I think most startups are going to be DAOs, and I believe that most enterprise systems will be controlled by DAOs too.
Motivelli, go for it. If you had to follow up really quick.
Yeah, I did, but I don't know if it's going to be a quick one, but I'll throw it to Dom and he can answer it quickly. I'll take it out of my hands. Dom, so I love the evolution of the internet and where it's gone from websites to RSS to portals to things like that. And I think what you say about startups and how they organize, and I love this idea of like the service nervous system. Like that's bananas to me. I'm just like kind of blown away. I have to like deep dive into that and figure out what exactly that means. But I guess like real quick, like, you know, I found that typically like most people don't want to do a lot of thinking on the internet. And when all these Web3 services start to come out, and I guess for IT and for infrastructure, it really makes sense. But like, you know, what is the vision for the world's computer where users can just not think about it? Is it more like Web 2 like we have today, or is it actually more like Web 1, like going back to 94?
No, I think it's more, everything's going to get better. So I, you know, just, rewinding a bit to some of the early discussions, like, you know, there's a saying in venture capital, don't mistake a clear view for a near thing, right? You know, back in 2015, you know, we could see that, you know, the future is world computer and we'll eventually have a blockchain singularity. But, you know, to make that happen, you have to have all these different pieces in place. And, you know, user experience is one of them. Most people are not going to care that much. Well, people, you know, people are going to care about the experience, albeit things like tokenization will greatly enrich experiences and create huge incentives. And that's only going to be possible in services that are end-to-end decentralized for regulatory reasons, right? So, yeah, people like users of OpenChat, like there's these people who got diamond profile or something. I know that they know they're not bots, and I think they're gonna give out chat tokens to those guys or something. Like, you know, but then there's other rounds. They're gonna get like ways of making sure that people aren't bots, and so, you know, they're gonna make like millions of users into founders, right? And that represents, you know, a change in experience because people are now having a different relationship to the services they're using, right? They're sort of part of them. They're a founder. They're advocating for it. They're maybe creating content or doing content moderation or whatever it is and getting rewarded for it. So, you know, I think that's how users will learn about Web3. It won't be like, oh, I want to use this because I care about decentralization and it's running on the internet computer and it's got a DAO in control. Most users are not going to be like, thinking like that. Of course, like there are crypto enthusiasts who choose to use, you know, real Web3 services for that reason. But the mass market isn't going to care. The mass market does stuff because, you know, there's some kind of incentive. It's a better user experience or more enjoyable, more fun, or you get rewards, right? And so it's through these things that we have to win the mass market. And I think, I do believe that, you know, in this model where, number one, you have pervasive tokenization. So if you've got open chat, you know, soon you'll be able to send like Satoshis in a chat message and stuff like that. I think some's already been distributed, like a test amount. People have got some of that. There are Satoshis flying around on open chat. You know, that kind of thing, like new functionality, that's something people want. But this thing where, you know, you can become a founder of the service and part of it, I think that will change people's relationship with services enormously. And of course, people will be pleased to know, I think, once they've been brought in by that, you know, they'll also be pleased to know that this is like a protocol, right? And it's a community run service, and there isn't like, you know, Mark Zuckerberg behind it who's you know, czar of everything. And so I think that's how, you know, it's by incentives that people will come in, you know, better user experience, richer online experiences, and you know, this kind of updating of the relationship, transformation of the relationship between the user and the service. That's why people will come in. And I think, though, eventually, though, when people, you know, they get chat tokens and they realize, well, they can trade them, but they can also, like, you know, stake them in the governance system and be part of governance and things like that. I think that's where, you know, people will be brought in for other reasons, but then they'll start to become advocates of Web3 themselves when they see how it works. But it's very important that, you know, we focus on the user experience. So, for example, that's why we invented this thing called internet identity. So on the internet computer, you can authenticate in a cryptographic way just using the fingerprint sensor on your laptop or Face ID on your phone. And that's actually making use of a protocol called WebAuthn, which allows content inside the web browser that's been served by smart contracts to interact with, I think, a TPM, trusted platform module chip inside the device where the private key actually lives. Your private key can't be stolen because it's inside the chip, and like the session gets sent inside that TPM where it gets signed, right, and then put back in the web browser via WebAuthn. But it's very convenient and it's getting better all the time. I mean, it's still not as good as it could be, but it's vastly better than it was like a year ago. And that's pretty cool because, you've got cryptographic authentication where you don't lose your keys, but your keys can't be stolen. You can't even access them yourself. And, you can authenticate using biometrics like Face ID or whatever it is, but that's actually activating, causing the secure hardware to send a session to the TPM in the device where the private key lives and the signature is being added. But for the user, despite it being cryptographic authentication, for the user it's really straightforward. It's like you go to a website, fingerprint, Face ID, whatever it is. You can use a YubiKey or a Ledger wallet too if you want. And so that's I think it's an example of the way that the emphasis that we place on user experience. Like, we want to give people the advantages of crypto. Like, you need to be, obviously usernames and passwords are bad. And we want to give people the advantages of cryptography, where they're authenticating using their key pair. But at the same time, we want to make it easy. Like, we don't want users to be writing down these seed words. That's madness. Like, how's my mother? And my mother only just recently upgraded from a Nokia phone to an iPhone or something. She's not going to be able to write down a seed phrase and keep it safe. It's not going to work. Like, it needs to be something that just works, and that almost certainly means that the keys are inside secure hardware. Even you as a user don't have access, because if you as a user have access, then somebody else can have access. And then your activation of those keys, involves like biometrics. So, like on the MacBook, you press the fingerprint sensor, activates the secure hardware, takes the session from the web browser, puts it inside the TPM chip, gets signed by the private key. Signed session comes out back into the web browser, and now you're able to access the Web3 service. Usability is essential in all of this.
Brilliant answer. I can probably say that about every single question that we've asked on this space, Dom. It's been an absolute pleasure. We've learned a tremendous amount, not just about ICP, but about the future of Web3. I know that you went way over your allocated time, so I deeply appreciate that as well. And if you have any closing thoughts for the audience before you head out today, go ahead and share them now. Otherwise, I can't say this enough. It's been an absolute pleasure having you on.
Just closing thoughts. Thanks. I can see there's quite a few, quite a large audience, and thanks for your interest, and stick with us. And crypto winners always come to an end, even this one, and just focus on the next thing and building. And no matter how bad it gets, in the end, the pervasive, just the power of crypto technology will see it through.
Couldn't agree more. Whale Coin Talk community, thank you for joining. This is another episode of The Aquarium, and we had ICP in the house today. Remember that everything you hear on these broadcasts is meant for education.